Yes, hello friends, welcome to BISP Solutions. BISP Solutions is a tech company and provide technological solutions across the world. Now this is our another bootcamp session in this machine language series. So today we are going to see purchase pattern analysis. First of all, let me give you one scenario. Now, for example, you also might have observed in your daily life. For example, if there is a tailor, right, and if you get your clothes stitched from a particular tailor. Now suppose tomorrow if that tailor has relocated to some other place in the same city, and it is a little bit far away from your house, but still you will go to that tailor. Why? Because you have trust on that tailor. This is called human nature, behavior of the buyer or the customer, behavior of the customer, right? You will not previously that tailor was residing in your area, so you were going to that particular tailor, but within few years you have built a trust on the tailor, right? Now tomorrow, after 2-3 years, that tailor is located like 5 kilometers away from your house, but still you will go to the same tailor. You will not change your tailor, right? This is called customer behavior. Second example, second scenario, let's take an example of hair cutting salon. Suppose you are going for a haircut to a hair cutting salon which is located just beside your house, right? Now initial 1 year or 2 year you are going to that specific hair cutting salon, but tomorrow, suppose after 1 or 2 year, if that hair cutting salon shop is shifted to let's say 500 meters away from your house or 1 kilometer away from your house, then you will not change your the barber shop. You will just go to that hair cutting salon which is 1 kilometer away. That means you will not change your haircut salon shop, right? So this is also called as a customer's behavior. Once a customer comes to you, he builds a trust with you, and then he never wants to change. Similarly with a general store or general grocery store, right? Before this online shopping site, there were only general stores where the person used to go and give his receipt of the items to that particular shop owner, and then at the evening the shop owner sends it through a labor at your doorstep, right? So I am talking about that scenario where the customer does not want to change the vendor or the client, but he still goes to the same shop. So this is called purchase pattern. So today we are going to study on this purchase pattern analysis using deep neural network. For example, I am running a general grocery store, and there are certain customers, like let's say 100 customers in the city, that I know that they will definitely come to me. So this is previously, before these machine learning evolution and all these things comes, the owner of the shop or the businessman, he used to predict by his own analytical skills. But nowadays this thing can be done with the help of machine learning, also deep neural network. Now see, what is this purchase pattern analysis? Now see, purchase pattern analysis, let me make it a little big. Okay, purchase pattern analysis, also known as buying pattern analysis, is the process of studying consumer buying habits and behavior, right? Or buying habits, or like, let's take the services, right? We are going to a tailor, that means we are taking the services of that particular tailor. So it evolves examining how often and when and why customer make purchase and what factors influence their decisions. First of all, need recognition, information search, evaluate alternatives, and then purchase decision and post purchase evolution, right? So this is all done with the help of machine learning. Now the scenario is clear that we are analyzing the purchase pattern behavior. I know that my customers are there in this city, they will definitely buy from me, but there are certain new customers also. For example, let's take an example. My shop, the general grocery store, that is located in the middle of the city, right? Now all the customers which are under the 1 kilometer radius or 2 kilometer radius, they will definitely come to me, I know that. And the one customer who is located in the outskirts of the city, for example a little far away, 2 to 3 kilometer, but for him the very closest shop is my shop only. So according to the analysis, he will definitely come to me only, because if he select any other shop which is let's take 10 kilometers away from his house, that would not be convenient for him, right? So that is why it is written here. Look at this: need recognition, information search. When he will search for the general store, say he will search for all the information, then he will evaluate the alternatives also. What could be the alternative, right? Then he will take the purchase decision, and what will be the purchase decision? Based on that, post purchase evolution. Post purchase means once he take the grocery from my shop, then according to my behavior and my communication with the client, remaining depends on that only. So that is why this complete thing is done with the help of trained model. What we do, we provide the historical data to the machine, and that machine will evaluate and try to extract the pattern. That machine will extract the pattern, that suppose if a customer is buying small things from you, for example just beside my house there is a grocery shop, not a very big shop, but it's all the daily use items are available there. So for small things also I go to that shop daily. So suppose tomorrow that shop is located is shifted to any other location, or I shifted to any other location. So what will be the probability whether I will come to him again or not? So that depends on the locality where the shop has shifted or the customer is shifted, right? If there are some other options are there, so definitely I will choose that option. And if the shop, what we say, I have a good bond with that shop owner and the trust, and he provides me some facility, so definitely I will go to that previous shopkeeper only, whether doesn't matter he is 1 kilometer away or 2 kilometer away, right? So previously it was done with the help of analysis. Now it is done with the help of, we can do it with the help of deep neural network. And this deep neural network will save your time, and it can process on over 1 lakh of records. So this technology helps the businesses, right? So that is why what we have done, we have taken the data from the NetSuite ERP, right? We are having the data from NetSuite ERP, and let me show you that Excel sheet, purchase pattern Excel sheet. Now look at this first. Let me open this Excel sheet and I will show you, and then we will do the analysis on that, right? So we have designed a report in NetSuite in such a way that we should get the customer ID, we should get the product ID, and then look at this. Suppose let's take these are my items that I sells, right? These are my customers, right? Items, purchase, how much purchase sold to which customer. For example, again the same thing. Daily a family needs 5 liters of milk, and daily that the customer comes to the same grocery shop for 5 liters of milk. That means it's their daily need. And definitely tomorrow, if that shop is shifted to 500 meters away from their house, or 700 meters or 1 kilometer, but still he will come, because it's a daily basic need of that family. That 5 liters of milk is the daily basic need. He is having a big family, so that's why he needs. So he will go definitely. So this is called the what we say, evaluating the probability, right? So now see here, purchase type, one time, regular. Suppose it is based on the frequency, right? Regular, like this is our regular customer, right? Let's take an example. 1623, right? 1623, this is the regular customer, right? So this historical data has 5000 rows, right? That means we are maintaining the data of daily selling, right? So daily sale data is here, and now we are going to predict the probability of the customer, that how we can retain the customer, right? So now the idea is clear to you, all of you, that we are going to analyze, we are going to predict, or we are going to analyze the purchase pattern, right? So that is why we are taking the data of NetSuite ERP, okay? Because we are trying to establish the connection between this technology of DNN, that means machine learning technology, and the customer, shop, no, not shop, business and technology. How technology drives the business, how technology makes the task easier for the business. If we previously, before let's take 90s, before 90s decade, there were no laptops, no computers, no IT technology, so the customer used to predict by their own. But today we are having this facility, right? So let's create one more IPyNum file, that is interactive Python notebook. Now let's see, I have already created this. So now it would be easy for you, all of you, to understand, because the scenario is clear now. For this we have taken the Excel sheet, that is fine, but to work on that Excel sheet, we have to pull some libraries, okay? So these are Panda, is a very well known library used for data analyzing, and then NumPy, and then Torch, then the neural network. All these are libraries we have already using for the last few sessions, right? So let's take, okay, now all the libraries are pulled. Now load the data set. Now this is the purchase pattern CSV that I already shown you. Now DF, now look at this: customer ID, product category, purchase amount, date, and purchase type, right? This is what we are pulling, and this is the sufficient data that we need to predict, right? Then you will see here, date is converted into the date, month, and year. Okay, right now this is done here, but date is not required here. On which date which customer purchased what, we are not concerned with that. We don't have any use in that, right? So month and year is sufficient for us, right? So month and year is sufficient for us. Then what we will do here, let's see this. Look at this, category columns, product category, right? What we have done here, category columns, product category. See, first of all, let me explain you DNN. All the machine learning algorithms, they work on numerical data, right? So that is why we have to first encode the data. See, category columns equal to product category, and then suppose if I write here call in category columns, what we say, label encoder, and then df call le fit transform df call. Now if I put here instead of this get calls, let's see, this is the product category, right? Get calls, okay, this is showing an error, okay, no problem. Now see here, we have taken this product category in cat call variable only, and then we have encoded this, so all the product category is converted into numbers, and after the requirement is finished, we can convert them into words also, right? So that is also possible. Then you will see here purchase type. Purchase type means this purchase type, again this is an alphabetic value. So look at this, target encoder, label encoder, then purchase type, target encoder, fit to transform, but we are again converting it. Now again df, let me show you this, df, look at this, this purchase type is also converted into 3012, that means one time regular subscription based, right? So this is how it is converted. Now let's see this split feature and target. Okay, now feature and target means the independent variable and the dependent variable. Independent variable means already which are available, that means customer ID is available, the product category is available, purchase amount is available, purchase type is available, month and year. Now what is not available? Purchase type we want, right? So purchase type, from here X purchase type we removed, and in Y we have given purchase. So now if I make it this, look at this, okay. Now what we have done here, scale, look at this, scalar equal to standard scalar, x equal to scalar transform to fit, right? So if I make it like this, look at this, standard scalar, it converts the value from -1 to 1, that will be easy for the processing, right? That will be easy for the processing. For example, just like that, if the data is provided to the in SQL, the data is processed based on the ID, right? So it will be easy for the SQL engine to work on that, right? Similarly here -1 to 1 will be converted. After that, let's see this, here you will put x train, x test, y train, y test, right? Train test split x. Now here train test split means train size, that is the 20% is used for test, and random state 42, that means data should not shuffle, okay. Then let's see, this is the purchase data set, right? Purchase data set, we have created one class and one function here. These are the two functions from where we will pass the data, right? Right now we have not passed any data here, okay. Let's go again, train data set and tester data set. Look at this, train data set and tester data set. Now train data set, purchase data set, x train, y train, and test data set, purchase data set, that is y test, x test, y test. So train of both the variable and test of both the variable, right? Now what we are going to do here, train loader and test loader, we have to load the data also, right? Data loader, train data set and test data set. So now we are going to load. After that we will create one more model, that is purchase model, right? Just a second, okay. Now what we are going to do here, purchase model. Before that, purchase data set is created. Now purchase model is here, right? So from here, return self next x, right? X value will be provided from here, and the model equal to, look at this first, here, model equal to purchase model input dimension x shape 1, that means the x shape 1, that is the first value, first column. Output dimension length np unique y, all the unique will be taken. Why? Because the customer IDs will be there. The first is customer ID, right? So all the customer ID uniques will be taken. Then criteria neural network dot cross entropy loss function is used, optimizer torch. So learning rate is 0.001. This is all technical, so we will focus on the process exactly. Now look at this, epochs. Epochs means we are running the repetition. Right, now you will see epochs model train correct total, training the model. We are now training the model. Now yxb and yb in train model, train loader, that means separate the value in xb yb. If I show you, let's wait, train data set. Okay, here you can see for xb yb is where we are now separating the data. Just a second, xb x train. Okay, now if I enter this, look at this, the epochs is running. For xb and yb we have separated the data in train loader. Then whatever the outcome, look at this, prediction will be stored in out variable. Okay, and then calculate the difference between the actual and predicted, right? After that, optimization zero grade and loss backward, that means back propagation, again it will be running from the beginning. Then predictions are done here. This is all technical part, and after that accuracy is calculated. Now see here, every epochs, for example total 30 epochs are executed, that means 30 repetitions are done, and you will see here the loss is decreased, loss is reduced. Look at this, somewhere it is reduced or somewhere it is increased. Okay, after that accuracy also it is in constant, maximum time it is constant, but here it is increased, sometimes increase, sometimes decrease. Okay, after this we are going to evaluate see here model eval, and then all the variables we have taken, then xb yb in test loader, and output is stored into the out variable, and then all the predictions extend predict dot numpy, and then all actual, that is extend yb dot numpy. And in this way we calculated the accuracy. The accuracy is near about 58%, not that much good, but yeah, 58%, more than 58, 60, 70% is required. So if you go here down, now see here it is showing the accuracy is increased, right? In every epoch the accuracy is increased. Okay, now let's come to the next part, that is plot actual versus prediction. Now look at this, actual versus prediction, purchase pattern and sample 1000, right? So if you see here sample 100, if you see here, whatever the actual value and whatever the predicted, it is predicting the 1, right? But it is not taking the value 2 or 0 or less than 1. So in this way it is calculating, but that is why it is called as 58% accurate. Now let me open this also. Look at this, predicted new. Now we are going to predict the new data, new variable. So predicted, we have created one function, and then we are going to pass this pass a value to this function. So let's check it out. Now see this. Now prediction for new sample, that is regular. We have taken 1634 is the value, 1634. Then 2 is the purchase amount. No, not is the, it's a purchase, it's not purchase amount. Wait. 2 is the purchase category, and then the amount. 2 is the purchase category, and then the amount is 120. And what is 4? Amount is 120. Okay, 4 means purchase type. No, not purchase type, it's 4 is the month, right? It's 4 is the month, and 2025 is the year, right? So let's look at this. 1634 is the customer, then 2 is the purchase category. Let's make it here correct. Purchase category. Amount. Okay, now let me show you one more thing. See, one time, if you see here 1630 we have used, but suppose if I used here 1844, right? 1844. Let's go here, 1844, and purchase category is 3. 1844, purchase category is 3. Purchase category is 3. And if I make purchase amount is like 10, if I make it purchase amount, and the month is, the year is 2026. Purchase category is 3. Let's make it as 3. Yeah, 3 is okay, and 4 is the month. Let's make it 3, right? That means it is showing regular, right? Because since 2022 he has been buying the goods. So that is why this is how we predict the data. Let's have a quick recap first. First of all, let's again focus on the scenario. Scenario means we are just predicting or analyzing the purchase pattern of the customers. What will be the purchase pattern? Suppose tomorrow if I relocated my shop or my big showroom to some other location of the same city, so what will be the crowd, what will be the analysis, or what will be the probability of that crowd to come to me? Otherwise, if it is showing one time, then it is better to move, not to move from that location. For example, let's take an example. If a tea shop owner, tea stall, he is running his tea stall in front of a college, right? But tomorrow if he relocate his shop to the highway, so, and the college is located in the middle of the city, so who will go there? That means all the customers of that college, they will not go onto the highway to have the tea. they will go nearby shops. That means this is what the analysis that we are working on. If I am having a big showroom and if that item or the product, the usage of that product is having some influence on the person's life, then definitely I can relocate my shop to another location of the city. But if the item that you are selling is not having that much impact on the person's life, then definitely it is better to think twice before relocating your shop, right? Just as example, if a sari shop or a tailor or a hair cutting salon or a garment big showroom, people will visit there because they are having trust and they think that when we are spending this much amount, then it is better to go to that particular shop because there is a guarantee that he will give you the best quality clothes. But if we talk regarding a tea stall owner, right, he is running his shop in front of the college and making big profit daily, because in a college there are near about 1 to 2,000 students, right, daily. So they come to his shop and one tea they take something else also, right? Now here he is getting the profit, but if he thinks that if he relocate his shop to somewhere else far away from the college, then there is no probability or no chance of retaining the customer. Why? Because college student, for only few amount of just for a cup of a tea, they will not go like 1 or 2 kilometer away, right, or on a highway. So this is how we predict the pattern of purchase, what thing you are selling and what impact that thing is putting on the customer's life, right? This is all about the purchase pattern analysis. Okay, so this is the scenario that we discussed today, and this is most important scenario. So let's take technically first how it is done. First of all, bring the libraries, then read the Excel sheet, then convert that alphabetical value into the numerical values, and then train, test, split, convert them into the scalar, that means -1 to 1, and then train, test, split, create 2 variables x and y, then start training epochs, start training the data with the help of epochs, and these are the repetitions, then with the help of which you calculate the losses and the accuracy. Here, after calculating the accuracy, and here you will have to analyze the data on some new data, right? Analyze your script, or we can say the algorithm on new data. Here we have given the new data, and that algorithm has given you the output, that prediction for new sample, that is the regular. That means this customer will be retained by you, and he will definitely buy the items from your shop, right? So this is how we calculate, right? So my suggestion, my recommendation to you is that read this watch this video twice, thrice, and if you have any doubt, you can direct put in the comment box. I will be happy to help you there. And those who are the first time viewers, those who have not subscribed this channel, please share and subscribe my channel, right? So guys, today we are concluding here only. Tomorrow we will see some other new topic, and again I am suggesting you to watch this video twice, thrice, so that you will get a proper idea of this, right? And tomorrow we will see some new topics. Okay, thank you guys.